All right, good morning, everyone. Let's get started with today's class. If you're watching online, I do ask that you turn on your cameras. Okay, so last class period, we were doing the digitizing exercise. If you know, I know that some of you may have had some issues. So we're gonna finish that today and then talk a little bit about an assignment and also the mini project. So maybe let's just start by finishing the digitizing first. So if you so right now I am on my course main folder. We would go into the 05 digitizing. That's where we created the code data and output and also the R project. Make sure you do launch RStudio through this RProj icon here. If you don't have yet your project launched. Just again, we just want to make sure that we have our file paths working correctly, which the R projects help us with that. Okay, so let's just go to the top of the script here. In my case, so things I want you to make sure that you have on your side. Number one is you want your 05 digitizing R project to be showing up on the top right. If it's not showing, then you're not in the right project. Make sure you are in the right project. And then we're working on this partial script. Right now on my side, my environment is empty, which is something that we normally wish that it is. And we talked about this in the past. If your environment is empty as well, that means you're gonna have to digitize again, because last class we did not get to the part where we actually exported the shapefile that we digitized. So let's just go through that again right here. So I'm just going down the script, make sure that you load the packages. So hit that play button. If you have any install.packages functions active, make sure you deactivate them by adding that comment. Next, we started off with the centroid. So again, if you're working with a grower, it may be the easiest for them to just say, these are, one spatial coordinate of my field. I just found this on Google Maps. I'm just sharing that with you. It's really easy for them to share that information with you. So here we're just mimicking that process as far as you're provided with a pair of coordinates in longitude and latitude. We transform that just from a simple data frame into an SF object. We're using this function here, STSSF, and then we assign the proper coordinate reference system, which in this case was WGS84, which the EPSG value for it is 4326. Make sure you run this chunk here in a way that this object appears on your environment. Then we just use map view to look at the centroid and look at it in space, right, in an interactive way. So if you zoom out a little, we may see the field. If you come here on that stack button and you click S real world imagery, it will show you a satellite imagery. And this was the field that we were playing with. I do have a note here that, so last class period, a couple of students were having issues as far as showing the base map in right below the chunk where I'm seeing right here. So maybe you could see the base map once you if this window was showing on the viewer pane, which is going to show later when we do digitizing. But under the chunk, some people were not being able to see it. And I think we found the reason why. So it seems like, especially if you're using Windows, on Windows, there seems to be a limit of characters to file names and to file paths, in a way that if your file name and the path that it's embedded with is longer than a certain number of characters, it gives you some errors. And I just want to show you here what we would do to avoid that to happening. So if you are on Windows and you for some reason cannot see any of the base maps here when you do use map view, or maybe you're having some other issues. I know another student was not being able to print a data frame right below the chunk, was also given issues. And we found out that the issue was with the length of the file name here that I'm sharing with you. So if you are having issues of not showing the base map, maybe one of the things you can try is just renaming. So if you just click on that partial, I think it has this button here, it's to rename it. So you can just rename it to something shorter. It could be like, I don't know, even if you want to try just 0202, you know, it's not a very intuitive name. I would not recommend that you rename this if you don't have to. But if this is the issue on your side, try that and then try to restart R, try to run again. You may be able to recover your ability to show base maps in map view. Again, this is a Windows related thing. I'm not sure why that happens, but if it does happen to you, this is the solution that we found out that works. Okay, so we inspected that our point is right in the middle of this field. So now the next step would be to digitize the boundary, right? So we already worked on this code here. So basically what we're doing is we're starting map view. And just to recap here, so if we just look at the map view itself, it does not have a digitizing menu option, right? Map view by itself does not give you that option. So what we're doing is we're merging the capability of interacting with the map that map view gives you with a add draw toolbar function that comes from another package, right? And then we're assigning all this to this object that we're calling digitizing. So if you run first, and then you kind of run this digitizing object once, now it's going to, it's showing up here that we can digitize on this window. However, if we just start digitizing here, I don't think it's going to be saved anywhere. So what we do want to do is go to the next chunk where we then give this digitizing object to the function added map and then assign this to this object boundary. So what happens is in this case here, this function added map is going to further allow you to save whatever you digitize to an object. And that is really where we can then retrieve back that boundary in some way, right? So if you come on this next chunk here, so all this code we already did last class, I'm just going over this again. If you run this object boundary, it's going to pop up here on the viewer pane on the left, sorry, on the right-hand side. What I recommend you do is you click on that button right there to expand this window. So this should open up in your browser to make it easier for you. And before we start digitizing, I just want to point something out that I noticed was a reason of confusion last class. As you notice, this chunk here is currently running, and it's not because it's a heavy chunk and it's doing a lot of things behind the scenes and is ready to show you an output. It's not that. It shows that it's running because you have this active window here that is going on in the background. So your R is kind of like focused on that, and it's not going to let you run anything else until you close this interactive window. So that's why your chunk shows up as running like that. Now, if we go back to, if you came here and you expanded your window by clicking on that arrow up icon right there, and it went to your browser like you went for me, this is where you would digitize, right? So we did this last class already, but just as a reminder, to start digitizing, you would come here on the left menu where you have all these options. As you can see, there's digitizing lines, polygons, squares, circles, points, and so on. So you can do any of this right here. So let's say that this is your, I don't know, this is a grower's field that you're trying to sample and get some idea of soil sampling here, but you want to be strategic about the sampling because you want to sample from specific places of this field. You could come here and simply digitize points, just drop points here. And then whenever you come to this field, you would use a GPS to navigate to those points, right? So I'm just showing you an example that we did not see last class. This is not what we're doing today. I just wanted to show you another example of how you can use digitizing. On my side, I think I'm gonna cancel this because I don't want to save those points. That's not the goal of this. So I'm just gonna go back to our rerun that boundary objects for that added map level and then pop it out again so we can digitize what we really came here to do, which is a boundary. Okay, To do a boundary, it's that second icon right there, right? So if you come here, it's going to show you some stuff. You don't have to worry about it. You can just come here and start dropping points along this boundary. I do want to ask you to be, I mean, of course, there is a trade-off between how many points and how much detail you can do here, but try to avoid including trees here, because the boundary that you create right now, it's going to be the boundary that you're going to carry over with you till the end of this class. So if you can be precise, that's going to help you to collect or to arrive to precise results when it comes to the end of or when we're doing the management zone and so on. And then I just want to show here, lastly, once you think you got the proper shape of this field, you just click on the first point that you dropped, and that's going to close the shape. Once you do that, you don't see the points anymore. Make sure you click on done on the bottom right. That's what's going to tell this window that you're done and that you want to assign this boundary to that boundary object. So make sure you click on done. Do not click on cancel or just close the window, as that will not save your work. So I'm going to click on done.
Question.
Yeah.
With, excuse me, with that, I know you said you just want field area because that's all that we're working with at the moment. However, like with that one, I thought there was like a little area off to the side that was just like grass area, like not necessarily field, but it was a cleared area, like for a pivot to walk over. Would there be cases we might need to include that, like that little strip there on the side, or?
So you mean, I guess I'm not quite sure what you're referring to. Let me pop this out here to make it easier for us to see. So what part of the field are you referring to?
The far right side,
Far right side.
right there. Yep. See
Okay.
that?
Yeah.
That looks almost like just like a little grass area, like it's cleared for a pivot to be able to walk over it, but it's not actually in production. I was just curious if there's cases that we might need to include that in some and not in others.
I think it will depend on your goal, right? So our goal here is to basically, so we're going to be working with especially the yield monitor data, which is the first like field related data we're going to be working with. That is going to only comprise the data within what we are seeing as the field, right? So we're not going to have yield data for this grass area. So in our case, I mean, I would not include that grassy area in our shape. But if for some reason, I guess that's a good question, because really what I would recommend is whatever is your goal, that you try to draw a boundary that makes sense to that goal, right? So let's say for some reason, I don't know, let's say that perhaps you are just trying to make some mapping here, and you want to know what is the soil series of the field, including this grassy area, because maybe you want to see if that's the same soil series, and that may help you decide if you want to put that in production or not. I'm just making something up here, but let's say for some reason that your goal was to assess what was the soil series within that grassy area, then I would include in the boundary. But in our case here, that is not the goal. The goal is to really relate a lot of things of this field to yield, and yield data was only collected within what we see as the field boundary and not including the grass area. Does that make sense?
Yes, sir.
Yeah, that's a great question. Yeah, so I guess again, it will come back to your objective, right? So you want to draw a boundary that is close enough, or that is close to the boundary of whatever you're trying to assess on that field. Okay, so if you are all able to draw your boundary, now if you just run this boundary by itself, so do not run the edit map again, because that's going to give you the choice of editing again. So just run the boundary by itself. You're going to see that it has a few different components here. So it has this $sign drawn, which is what you've drawn, edited, deleted, finished, and all. What I've been using is the finish component of it. So if we just do a map view on that, just to see if really what we did is matching. This is what mine looks like. Yours is okay if it's a little bit different, because we're all doing on our sides, it's not gonna be exactly the same. But as long as you're not getting any tree areas and you're including, the main part of the field here, you should be good. Okay, let me just take a moment here and ask, was anyone not able to draw this? You were not, Ujjwal?
I have an error on the previous song,
On the,
creating map for digitizing.
on this one?
Yeah.
What is it telling?
Error in evaluation. Argument is missing.
Argument is missing. So did you include this after? Okay.
It was running when I ran the first time,
Okay.
and I ran it again, and
Okay, let me come to you very quickly here. Something here. So I'm just going to restart our session. And again, we can start fresh. Yeah, above. There's someone who. Oh, yeah. Yeah. Good eye, I did not see that. Okay, yeah, I think, so you're gonna be able to do that now, which while I think you should be able to do it as I'm walking through here. If you need more time, let me know. Okay, so, so I guess online, was anyone not able to digitize? All right, I don't hear anything, so I'm gonna keep going. So now that we digitized, what I want to do here next is to retrieve just that finished component so we can further work with that and export that to file. So if you come here on the next chunk, it's called boundary W. Let's give it the assignment symbol. So we're starting with this object boundary, which is the one that we digitize above. And if you add a $sign, it has all of those different components to you. We want to retrieve the finished one. So we're basically retrieving that finish from the boundary and assigning it to this object called boundary W. So if you run that, this should be a very simple SF object that is a polygon type. It only has one polygon. That's the one that you drew above on the digitizing step. And so the next thing here, again, I just want to use a map view for us to look at it and make sure that it is what we intended. So if you come on the next chunk, just type map view, and then let's call boundary underscore W. And it should look like what you digitize above. This is what I see, and it looks right. Okay, so we use a centroid to find the field, we digitize a boundary, and now we assign that boundary finished product to this object called boundary W. However, this is still just an object in R, right? It is not a file that we can use for something else. So our next step here is going to be to actually export this to file so we can use it. So again, for now, this is just an object. We do want to export this to file. When it comes to exporting a vector geospatial data to file, most commonly people would do this as a shapefile or .shp. I do want to show you how you would export as a shapefile, as that is the most common, but I also would like to offer you and show you a better alternative after that. So first, let's just go ahead and export as shapefile. Now, we are exporting a file. Every time we're exporting a file from R, we're gonna have to use a function called write underscore something. In this case, so if you just start typing write, you're gonna find a lot of options here for CSV, Excel, a lot of stuff. What we need here is write underscore SF, because this is an SF object, and that's how we would export it. So the first thing that we give here is the object name. That would be boundary underscore W. Let's give it a comma, break code. And now the next thing here we give is the path and also the file name and extension. So open close quotation marks. As you probably know by this point, we are inside of the code folder. I want to go to the output folder. So need to get outside of the code, that's .. If you hit tab, you should be at the main root of your project. You can select the output folder. And now I want to call this boundary. So that is the name of the file. And then also here is where we give what's the file extension that we want. So this would be .shp for shapefile. Before you run this, I do want you to add another argument here, which is called delete underscore DSN equals to true. Let me tell you about what this is. So if you don't have this argument here, the default behavior of this argument is false. And in that case, what happens is if I export this shapefile, this object, to this file here once, it's going to create what I want. However, if I run the same command again, it's not going to simply overwrite, it's actually going to append, meaning that instead of having one shapefile, now I have two shapefiles in the same, or two boundaries in the same shapefile of the same area. So it doesn't make sense. In this case here, it may not be such a dramatic difference, but sometimes we're working with thousands of data points within a given layer. And if you duplicate how much data there is there by exporting twice by mistake, then that is not what we want. So every time you use write SF, always make sure to change this behavior here to delete DSN equals to true. So you always overwrite instead of append if you do run this command twice. Okay, so go ahead and run this. It's going to give you a warning here. That's fine. And what I do want you, after you run this and we're exporting as a shapefile, because that's the extension we gave it, if you come here on your files tab, click on that R blue button, take you to the home of the project, click on your output folder. So you are not seeing the .geojson yet, but you should be seeing the boundary.shp, but also PRJ, SHX, and DBF. Now, we talked about this already, and shapefiles are the most common type of vector geospatial data that's used, mostly because Esri, the company that created ArcMap and ArcProducts, is the one that also developed the concept of a shapefile, and it was the pioneer in the industry. So most people that use geospatial data, vector data, use shapefiles. However, yes,
Mark said, and I have the same one and you have, and after that it says GDAL error one output slash boundary dot SHP does not appear to be a file or anything. But it shows up in the file.
it does show up. Okay,
So I don't think it's.
so maybe on the next exercise, we're gonna be importing this boundary. So at that point, whenever you import it, if it's not working, then it's probably because of that, and then we can get back to it. Yeah, so yeah, maybe that's a good point for me to ask. If for everyone, if you came here to, the main folder of your project, you went to the output folder, is someone not seeing the boundary DBF, PRJ, SHP, SHX? If you're not seeing, let me know. Okay, I don't hear anything, so I'm gonna keep moving.
And look at the code, where you retrieve the finish.
Yep.
Component.
This one here? Good. So just to finish the comment here on shape files. No, shapefile is the most common. People normally refer to shapefile, like if people want to talk about a boundary or maybe points or maybe a grid, they will tell you, oh, I'll send you the shapefile. What they mean is they're going to send you a vector geospatial data that's saved as shapefile, right? So shapefile is the extension and not necessarily the class of this type of data, which is actually geospatial vector data. And I'm telling all that because even though shapefiles are the most common because they were the first in the industry, as you can see, if I ask you, hey, can you send me the shapefile of your field? What some people would do is send you just the SHP file and not the other accompanying files. If they do that, you will not be able to open that file in any GIS. Does not matter what GIS it is, you're not going to be able to open. For you to open a shapefile, you actually have to have all the accompanying files with it. So you have the option of opening. So if somebody sends you an SHP only, you can bet that you're not going to be able to open. You're going to have to ask them, hey, can you send me the other files that were in the same folder with the same name, just different extension? Which, is not like it's not the end of the world, but it is something that can cause some confusion. So
Question.
Yes,
So, I'm also looking at boundary PRJ. Is that okay?
yeah. So
So-
boundary PRJ is one of those accompanying files. Yeah.
Oh, okay. Okay, so when you're gonna export that to somebody who requests that, so it will be DBF, SHP and SHX, right? Those are the three files that we need to send to be able to
Yeah, I
open
mean,
the file.
you have to send all of the four here. So I have one extra that you don't have yet, but you have to send the DBF, PRJ, SHP, SHX.
Okay.
However, I do want to show you a alternative. So there is this extension named GeoJSON, which is another file type that you can export a geospatial vector data under. So let's go ahead and do that as well, right? So the next chunk here that we have is basically going to be the same as above. So we're going to do a write underscore SF. We're going to call first the object that we're trying to export, which is boundary W. Going to give it a comma. Open and close quotation marks. We get outside of the code folder, go inside the output folder. I want to call this the same thing. So boundary. Now the difference is the extension here. So instead of .shp, we're going to type .geojson. So make sure you get the spelling right. GEOJSON, GeoJSON. And always remember to add the last argument, delete underscore DSN equals to true. So if you do this, you will now have this boundary.geojson file, which is a single file. It's not now 4 files. It's just a single file on your output folder. And that is normally within every time I'm working with someone that has a little bit more familiarity with geospatial data, I always ask, is it okay if I send you my shapefile as my boundary as a GeoJSON? If they worked with this, they would know what that is. Really, any other GIS would open a GeoJSON file the same way they open a shape file. It's just that I guess it's not as known and not as common for people to have run by this type of file. But anyways, GeoJSON is another extension, and it has the benefit that is just a single file. It's not 4 different separate files, and that can help you to avoid some confusion. Okay, so at this point, we exported this boundary. So this is actually now both a shapefile and a GeoJSON in your file system. It's not just an object anymore. Now we have exported this, and we can use this boundary for future exercises that we're going to do in this class. All right, this wraps up this exercise. Before we move on, I just want to ask, anyone has any questions or problems? All right, I don't hear anything, so I'm gonna just go ahead and close this. And our next point here is well, there are 3 things I want to talk about. So the next one is I have already created our script for next class. So this coming Wednesday, it's already on GitHub. So as you know, at the usual, you can go download it, bring it to your computer, or maybe do a Git pull if you have that working for you. I want you to call this 06 open data on your class main folder here. And as usual, I hope you're getting familiarized with the process already. So create 06 open data. You're going to go in there, create a code, data, and output subfolders. Also go on our studio and create a project at this level. And then I want you to copy that code that I shared on GitHub inside of this code folder here. We're not going to get started with this exercise today, but I do want you to be ready to go for next class, because then we don't have to do this setup here. We'll just get right into it. You have a question?
What's the code calling on? I just downloaded the folder on it.
So it should be 0205 open data partial. Should be the name of the code. Is that not on GitHub?
Yes, I got it.
Okay. Just a quick information about what we're going to be doing next class. So we're going to use the boundary that you created today to retrieve open source data related to soil series and also elevation for that field. So this again comes back to the idea of, you can have intelligence about a field. You can know about a field even before ever setting foot on that field, which gives you already some information, some background data that you can go to a field and already know what to expect to some extent. And this is important both for on-farm applications, but also for your research. So if you are going to conduct field research and you have a specific site, you want to know how is that site variable related to elevation, or how many soil series or soil types I have in that field. You can retrieve this data here. That's what I want to show you next class. And just I want to give you this heads up. We're going to have an assignment where after we go through this exercise, I will ask you for you to provide me with a field of your interest. It could be your farm, it could be somebody you're working with, it could be at least the farm where you think your studies are going to be in. And you are going to then digitize a boundary and then bring elevation and soil series data for that field that's important to you. We're going to go through that example in class for this field here that we're working with, but then I want you to basically reproduce that with a field of your interest. So just keep that in mind that, you know, if you don't know where, I mean, if you have field research or if you have a farm field that you're interested in exploring, keep in mind that you're gonna have to know the centroid of that field for a future assignment, probably next week. Okay, so once you have this set up, that's great. Again, we're not gonna be working with this today, but I do want us to be ready to go for next class. Next thing I wanna talk to you all here is I have a assignment that I actually posted last week, but because we did not get to the end of this exercise, I did not advertise it to you. So it is a reading assignment. I want you to read a paper and answer to me a few questions. So on the 2024 PPA that you just downloaded or pulled, there is this folder called 02 assignments. And there is a folder for assignment 03. So this assignment here in this folder, I have a PDF file of a paper, and then I have a QMD, a Quarto file with a few questions. So if you just open this paper here, it's a paper about the EO Editor 2.0, a software for automated removal of EO map errors. So I want you to go through this paper and read it. Either after or as you're reading it, I want you to answer the questions that are in this Quarto file right here. So if you do launch that Quarto file, you don't have to have a project for it. You can just launch it wherever it pops up. I have instructions for that here. Make sure that you fill your name under the author part of the YAML, and then answer these questions here right below them. And then I do want you to rename this file. So after you have, I think, regardless if you rename it the Quarto or the HTML, I do want you to render this, add your last name to the file name, and send me the HTML render version of this, which should be pretty straightforward because there's no code, it's just text. And then I have here that the deadline would be tomorrow, but this is not the case. So I'm just gonna change that here. So I want this deadline to be, so Thursday, 11:59 PM. So because of Friday, we're probably gonna start working with the EO data that I do want you to be aware of what we're doing through this paper before we get to that. So this would be due on Thursday, so that's February 8th, 11:59 PM. Okay, any questions about the assignments? All right, I don't hear anything, so I'm gonna move on here. The last thing I want to talk about is the mini project. So I think most of you have already shared your selections with me. And those who shared, if you know, we already talked about if needed, and then you're good to get started on the actual mini project. If you have not shared that with me, please make sure you do so soon because you're gonna need time to work on these things. And I do want to point out something here. I want to go to our GitHub repo of the class under issues. So we have here, so Kumar posted this question related to replacing D to NA in the code. Okay, so it seems like you already found a solution, Kumar, but I just wanted to bring this up is I'm not sure exactly how or why, but sometimes these data sets from NAS, when there's no data for a given county in a given year, they may code that as parentheses, uppercase D, parentheses. Which if you remember, if you have a numerical column, but any single cell of that column has a character, which in this case here, parentheses, D parentheses are characters, R is gonna see the whole column as character, right? Even if you have, let's say, 10,000 rows and one of those cells is a character, R is gonna treat that as character. So you, as Kumar was alluding in his question, you do need to replace that character, whatever it is, in this case with an NA. We did not go through this specific step in class because the data set that we downloaded did not have this problem. But you may run into this issue. If you do run into this issue, I think that Kumar may have found a solution here that you may help you as well. What I would say, Kumar, is if this is still an issue for you and if this becomes an issue for other people, even though we did not treat this error specifically in class, but we did treat something else similar where we had a character in a column that was supposed to be numeric, and we used a function called str for a string, str underscore replace, where you can use something like that. So take a look at this string R package, which is this package in R that's very useful for handling strings or characters in R. And that could also be another way for you to fix this. And as with everything programming, there's probably more than a few ways of doing this. Kumar, if this function replace worked for you, great. If other people find other solutions, great as well. As long as you get to the point that you need, that's the main point, the main part of it. I don't care how you get there. But, you know, I do propose some of the packages that I think may be easier to use. Okay, I think that was the only thing I had about the mini project. Make sure if you have issues, post on GitHub. If you see issues that people are asking questions on GitHub, use that opportunity for you to help them if you can, if you know how to help them, because that also gets you points, both by asking, but also by helping others. Any questions about the mini projects?
I do have a question.
Yes.
So when I pull the data, the NAS data, and then I pull it into the project, I don't see a table. What I see is a description DF with the number of columns. And then so what I did, I installed all the package and then put the library, the tidyverse, the read Excel, janitor, and GG themes, and I don't see a table. All I see are the descriptions DF with the rows and the columns.
Rolando,
Is that
if you can maybe take a screenshot of the code and the output and create an issue on GitHub, it may be, you know, easier for me or maybe others as well to understand what is going on and then be able to help you out.
okay? Thank you. I will.
Awesome. Yes.
I have an issue with getting my data
You,
to the NAS.
so the issue was like getting it from NAS or?
Just like the data item I'm looking at now, I can't really see. I'm supposed to have cotton and harvested area.
Mm-hmm.
And whenever I was doing the harvested area or acres harvested, it wasn't giving me, I couldn't do it at the county level.
Okay. So with cotton especially, let me pull that up here very quickly just to show.
I think I can get yield. If I said cotton and all up there, not in there.
Yeah, so I think with cotton specifically, it has a few more options than other crops. And the one that we normally want to use is the upland. Because it gives you, I think the first ones it gives you is not necessarily that. I think it's like a general, like just cotton. So we can just go through that here. Okay, so you have area harvested.
Yes.
Yeah, so I think that if you just click on that first option for acres harvested, yeah, so really what you want is to scroll down a little bit here and go to upland. So there is upland irrigated and unirrigated. I do want you to stay within upland acres harvested, which is like both, combining both irrigated and unirrigated. And that should give you the county option. Yeah, so with cotton, I think of all these crops is the only one that's a little bit trickier, just because it has all these different classifications for what type of cotton is going to show you the data. So did you find that?
Says cotton upland. Acres harvested.
Mm-hmm. Yeah, it's kind of like more towards the middle of that table there. Yeah, so that's what you, so I guess for everyone that had some category of cotton, make sure you get the upland option, which is going to be more towards the middle of this table here. Okay, I think that's what I
I
had.
have to ask.
Yes.
My two questions are, yeah, one of this, you have told about it in the class, but I'm still unable to understand it. One was, how do we eliminate a lot of codes in HTML file? And other one is, how do I break the lines? Because I tried to learn from that your video, but I was still unable to understand that. So those are my two questions.
Okay, so I'm gonna answer first the how, well, yeah, let me first help you with the how to break line, because that's gonna be the simplest, and I did not quite get your first question, but maybe you can repeat after I show you how to break line. Okay, so how you would break line is basically given two white spaces and then hitting return. So let's say I'm writing something here, and if I just hit return, this is not gonna break line when it renders. You need to give it, so two white spaces, that breaks line.
Okay. And my first question was that whenever I'm rendering this on my HTML file, all the data, like a long chunk of data, is coming in between the questions and answers. And you told me that you don't want to see that, and we have to eliminate that. But I'm unable to do that. So how can I eliminate those data?
So we talked about that as far as using like the head function.
Okay.
Yeah, so
So
if you put like df here, this is just gonna print the first handful of rows of that data set instead of all of it.
so basically in the chunk, my last code should be head like in bracket df, right?
Yeah, so let's say if you want to print that data, you would print just by giving it its name. But if that
Okay.
prints a lot of rows, you just wrap that around this function called head.
Okay, understood. Thank you.
Yeah. All right, let me take your attendance for today. So make sure you claim your attendance, and I think that's all. I mean, if anyone still has any questions or issues with either the class code or the mini project, let me know. I will stick around for the next couple minutes, and if not, you're free to go, and I'll stop the recording here.